All right, thank you. That was a great lead-in. If I could steal the stage for a bit, I think one of the really cool things that have changed with the ability to teach AI systems is our robots are now teachable by people who are not just roboticists. And so collaborative robots in manufacturing are a perfect example of that, but also like I can just talk to a robot and shape its behavior, right? I can do fine-tuning now using natural language, and that's pretty cool. I think that's going to open the space and the communities of people who can now engage and shape these systems, right? Not just use them, but shape them, and that's pretty awesome. So let's talk about people. Yesterday we chatted a bit about SDGs, and again, I'm going to focus here for today, talking about ways that we can make work more inclusive and sustainable for economic growth. And so I've worked on a few robots since working at Willa Garage. There's service robots, there's autonomous cars, there's underwater robots, there's flying things, right? And so my background is coming from just lessons learned from these spaces. And I know, we talked about humanoids. They are hot right now. But as we heard from our friends at PAL Robotics, right, they're not new. These have been around for many decades. I think because a certain someone decided to put a dancer in a robot suit, suddenly there's more fervor, right? And that's great, I think, for research, right? We're getting more attention, we're getting more resources put into robotics. But I just want to remind us all, like, this is not a new thing. We've been working on it for a while. I think another thing that we need to think really long and hard about is what is the technology readiness level, right, for actual deployment in commercial spaces. Back when I was also working at Willa Garage on this guy, this is a 32 degree of freedom mobile manipulation platform, right? It's this really fancy piece of hardware that's actually still running at MIT CCEL today. And is being used for research on making robots curious and able to explore the physical world in order to learn about the physical properties of spaces like kitchens, right? Which is kind of neat. But the dirty truth of this guy is even though researchers love it and roboticists love it, people don't really love it. Even when we gave them a $500,000 machine for free to put into their homes, they didn't want to keep it. It would destroy their rugs, it would scare their dogs, it would get in the way, and it would often trip the circuit breakers in their homes, right? So there are lots of practical issues that make this just not really ready for the home. So today I'm trying to work on more robots that are starting with a problem and then figuring out which robot or not robot is the right solution to fix that problem or to address it. We were inspired by Rosie, I will say. And so, in North America, we had the Jetsons, and Rosie was the dream, right? And so you can kind of see PR2's echoes of that design. I think there's a mistake that we might be making as a field in robotics. The first one is that these robots don't have to look like us to be useful. And the second one is that these robots don't need to replace us necessarily. I often hear the question, when is a robot going to come and take my job, right, if you work in robotics? We hear it all the time. And my answer is usually like, go spend some time with some robots and then see if you're still worried about that. They're differently capable than we are. And so I think we've set up this false dichotomy of fully manual versus fully automated work. And I think it's important to think about alternative futures that might be a little bit different than that and maybe a little bit more hopeful and productive and collaborative. So I think there's this space in the middle, right, where people and robotic technologies can actually share that workload. They can make lives easier, better, and safer for people, not just trying to replace them. And this is, again, not a new idea, right? So Thomas Sheridan, also from MIT, talked a lot about supervisory control of autonomous systems, right? And so we often talk about a human carrying a workload, right? And that can be hard. That can be hard in our bodies, that can be hard in our brains, they can make us tired. And so we often talk about how the robots are going to replace those people. But there's actually all this there's different configurations that I think are worth exploring that are in that middle, right? We can make people be able to reach farther, to run faster, to carry more stuff. We can make their lives easier by making that work more ergonomic for those people, right? And I think thinking of, when you get tired, when that pilot flying that plane that got us across the Atlantic Ocean, right, needs to take a break, it's okay to use the autopilot and be ready, right, to take over if you need to. But there's ways to share that are different than just thinking about robots replacing people. One of my favorite computer scientists talked about a nice way of doing this, right? And for him, he talked about the carpenter's trusty hammer and making these tools more invisible in use, Right now, we like to make shiny robots that get the spotlight and dance. But I think there are other ways that robots can exist in our world that are a little more invisible in use, right? They're just tools. They're tools for us to be able to get our work done. Merleau-Ponty, Heidegger, and James Gibson also wrote about the same idea of incorporating tools into our first-person experience so that we can just do more, right? I can just hammer the nail. I can get that board to stay in place in a way that's very different than what I could have done if I just used the body that I was born with. And so we're sort of re-embodying human cognition in that way. So what if we designed robots to work better with people? What might that look like? How could we make robots a little bit more like that carpenter's trusty hammer? And how might we design these robots to make people's work lives safer, easier, and better? I have one proposal. If we take the example of the pushcart, right? These wheels are an amazing invention. There's a reason that we use them in lots of robots. Legs are also amazing for different things, right? And so these pushcarts, like when you go grocery shopping, enable you to carry more stuff. You can carry it further. You can do it more safely. If the ground is level, and there's not big cracks on the floor, and there's not stairs everywhere, right? So there are limitations, but they do make us a little bit superhuman, which is cool. And I've spent time in warehouses where I've literally seen tens of thousands of these pushcarts in a single facility because they're so useful. But the people who use these face many challenges in their work. So if you look at a fulfillment center or a warehouse operation, you've got people who are pushing these pushcarts, dodging forklifts, searching a huge space that can be multiple football field sizes, American football field sizes in space. And the items that they're looking for are being moved around every single day. So this can be literally backbreaking work. They're doing a ton of walking, they're doing a ton of lifting, they're doing really cognitive demanding work. And so it's kind of not surprising that people don't last very long in these jobs. The turnover in these spaces is ridiculous, and the training costs a lot. And so for these people who are operating these warehouses, it can be a real challenge. They're facing a labor shortage, just like we're seeing in agriculture, right? During peak season, right now, during the holiday season, many of these warehouses have to hire twice as many people, and then they fire them in January, right? That's a rough labor market to be in. And so, what are they doing about that? There's basically two solutions. One of them is you make a dark warehouse where we don't need no stinking people, right? You automate the whole thing, but there might be a few people kind of left feeding the machines and keeping them running. The other way to do that is to build more humane warehouses where you can provide better working conditions, better tools, and better opportunities for those spaces so that they don't want to quit within a few months, right? And so I think here I've learned a lot spending time with floor associates trying to understand what makes a good day at work for them. And for them, it's just like being a high-performance musician or athlete. It's about getting into a state of flow and staying there, picking all of your orders on time and shipping them out accurately by the end of the day. Their favorite tools are things like forklifts. These ride-on forklifts literally make you superhuman. You can lift higher, you can lift more, you can get more done. They can be dangerous, and there is a learning curve, but there is a benefit to being able to use those. And for the rest of us muggles who can't drive forklifts, the pair of sharp box cutters are the other one that are really, really popular, right? Not having that in your back pocket is a problem when you have to deal with a ton of boxes and tape. And so just like the carpenter's trusty hammer, how can we make robots a little bit more like this? At Robust.AI, we're working on a solution that's a push cart. We call it Carter, and it runs around autonomously, just like the other mobile robots in these spaces. But most importantly, if a person needs to take it over, they just grab it by the handlebars and shove it. It's using, under the hood, really nice force controls so that it actually feels like an e-bike when you're pushing it. So even for me, I'm not that large and not that strong, I can push really heavy payloads and it just feels really light. So you use these, just like having a touchscreen. It speaks to the computer in the sky that tells you where to go shopping next and where to pick the next item. You can send it off on its way. It can self-park, right, and self-drive to go to the packing station when you're done with it. And even when it's running around autonomously, again, if you decide that you want to take it over, you think that it should pick a better path, you think it would be better to move it closer to the shelf to load a heavy item, you can just grab it by the handlebars. One of the problems that we see with many of these systems is that they get accidentally stabbed by forklifts because they scare people, they intimidate people, they're not easily acceptable in the workspace. And so we've been designing Carter to be a little more respectful of people. It actually gives them more space, it moves more cautiously around people than it does, say, around just an inanimate object like a box. And so I think, of course, you can imagine a future in which humanoids are doing these same tasks, right? They're picking up and moving boxes around. And actually, Carter plays really nicely with the humanoids. We've done a bunch of demos with them. But I think we don't really have the time to wait around for these systems to work. The labor shortages that we're facing are a problem today that needs to be solved right now. So I will just say a word of warning. When these robots are not designed to work well around people, bad things happen. So sidewalk delivery robots get kicked and shoved aside. Hospital delivery robots get accidentally turned off and shoved into the corner. And self-balancing robots get their balance tested, especially now that we've seen all these videos of people kicking them. Guess what people do when they meet a legged robot? And it's not nice. So I think we have this opportunity now to design robots that make people the stars of the show, as opposed to those robots, right? I think we can make the robots part of the supporting cast of characters that enable people to get their work done better, faster, and easier. So that's my hopeful vision of how we can get these robots to work better with people.
Thank you, Leila.
Thanks.
That was fascinating. Making people the star of the show.